by Dr. P. Chandramohan, Managing Director, Indomer Coastal Hydraulics Private Limited, on littoral drift along Indian coast. I welcome Dr. N. Kumarapan, Chair, IEEE Madras Section, Professor S.A. Sanasiraj, Chair, IEEE OES Madras Section, Mr. Rajesh, Secretary, IEEE OES Madras Section, Dr. Atmadan. I welcome you also. Now I call upon Professor S.A. Sanasiraj, Department of Ocean Engineering, IIT Madras, to give the welcome address.
So, very good afternoon to all. Thanks for joining with us in the webinar series. And this is at first in the series of in 2021-22. And there was a transformation of the Ocean Engineering Society chapter of IEEE. And we hand with IEEE Madras from 2021-22. And officially it took shape by a couple of months back. So we are starting our webinar series again in this year. And thanks for all of your support in taking our society interactions to the next level, and having a ocean engineering front of working personnel or only handful, but I think better all of us we meet on regular interval. Let us take this webinar series to be an opportunity to meet on regular basis. And I thank Dr. Chandramohan to accept to give the first webinar talk in this series. Thank you, sir. And so I request Nidhi to introduce the speaker.
Good evening, sir. Dr. P. Chandramohan, Managing Director, Indomer Coastal Hydraulics Private Limited, has done his BE in Civil Engineering and ME in Hydraulics. Thereafter, he did his PG Diploma and PhD in Ocean Engineering. He had been a scientist for 22 years in CSIR, National Institute of Oceanography, Goa. Subsequently, he started Ocean Engineering Company, Indomer Coastal Hydraulics Private Limited in 1998. He specialized in coastal hydrodynamics, waves, currents, tides, littoral drift, coastal zone management, marine EIA, design of intakes and outfalls. He has published more than 65 papers, guided 6 PhDs and 10 MTech students. He has executed 700 ocean engineering projects for various industries in India and overseas, like Maldives, Qatar, Sri Lanka, Mauritius, and Myanmar. He is the recipient of WASFIC 2018 Award for Environment and Technology and Lifetime Achievement Award 2018 from Indian Society of Hydraulics. With this brief introduction, we welcome Dr. P. Chandramohan to present his talk. Welcome you, sir.
Okay, thank you for your good introduction. I thank Professor Sanasiraj for giving this opportunity. Yes, we are all the same discipline. What I am going to talk about littoral drift is not going to be a new subject. Probably will be knowing much better than what I am going to talk. And I also thank Dr. Atmanan Saab for always carries a kind of consideration for me and my company, and also all the young academicians and scientists, engineers, being the member of this IEEE. And I will, before going to this littoral drift, my presentation, I have been asked to give a kind of about 1 hour to talk about littoral drift. And it is a subject mostly for the coastal engineers rather than ocean engineering. And when you come to the coastal engineering, you have kind of a major discipline like the waves, nearshore waves. There are professors in IIT also exclusively specialized on this wave generation, wave climate, particularly for Indian coast. And also people have a kind of distinct discipline on coastal currents. Coastal currents is one of the important aspects for which you need a kind of special attention and knowledge on that. then the forces acting on the coastal structures, the design of coastal structures, which IIT Chennai is doing a lot of designs on shore protections, port development, and all groins, breakwaters. That's another discipline, which is totally different from you have the knowledge on waves and other things. And another one aspect is the coastal modeling, the how when you want it design, how to handle the mathematical modeling and doing the defining the process and the impact. That's another discipline. So in that, the one is littoral drift. The littoral drift is the one which I started in 1985 when I joined IIT for my PhD. Normally, littoral drift is not liked by many people when they do the academic research. Mostly they go for structures and everything. But when you come for coastal application, everyone will end up in understanding what is littoral drift. And not only for design, even if you want to talk about the impact, the shore protection, you need to have a littoral drift. So that's why my kind of involvement started in the 1985 in IIT on littoral drift. That time Professor V.S. Raju was there and Professor Sundar was there. He was the only kind of coastal hydrodynamics person IIT that time. And Professor Mahadevan was there. So we started. And after that, it was a subject of my quench. Though I do so many things, always I just had a kind of my interest on littoral drift. And I'm going to just tell about even I have now brought out a book on littoral drift on Indian coast, which I'm going to publish in the coming conference. So though you already have some knowledge on littoral drift, you can take this occasion, if at all I know something better than what you know. Even if you ask a specific questions on any particular part of the Indian coastline, I think I can try to explain that. So with that, I will just start telling. I have planned this talk as what is in general is like a sediment transport close to the coastline. What are the different type of transport? That what is littoral drift, and what are the factors causing the littoral drift, and because of that, what kind of the changes we expect in the stability of the coastline, and how to predict the littoral drift, and how does it change along the entire coastline. Like that, I just put, and I am just giving you like a basic kind of information. So in between, if you need anything, you can raise your hand and we can stop, because we have a very long time. We can discuss, so that rather than giving a very long talk for 1 hour, we can have a brief talk in which people, if they have some kind of doubts or anything, we can understand, make this opportunity to understand a little better. That will be more useful. So let me start doing the present my PPTs. Then we can go one by one. Will it be okay? Good. All of you would able to see the PPTs?
Yes, sir.
Okay, so I'll proceed. What a number. So இது எங்கப்பா பண்றது இது? Okay. So it is not only for me, even the faculty members of IIT and NIOT scientists. It is a privilege to a person, very limited people having the opportunity to work on the ocean. Although we have 3/4 of our earth is covered with ocean, very limited people only had been given by the God the opportunity to work about the ocean. In that way, I thank God, my Lord Murugan, for giving me the opportunity of having spent 40 years about the oceanography. And today's talk is about the littoral drift. And littoral drift basically if someone asks what is littoral drift, we should not confuse them, telling so many equations, lengthy definition. It is the sand moving in the wave breaking zone. That's all is the definition for the littoral drift. Drift of the sand or sediment moving in the breaker zone, particularly parallel to the coastline. This is the basic definition of the littoral drift. And this littoral drift kind of being uh, called by different synonyms by different oceanographers or physical oceanographers or geological oceanographers or coastal engineers. They call either a littoral drift or littoral transport or longshore transport or longshore sediment transport, longshore drift, like that. They call it different names. Ultimately, the perfect one is called the longshore sediment transport, but in a more general term, we call littoral drift. And why one should know the littoral drift? Yes, unless a person is working very close to the coastline, many of the people who are studying about the offshore or about this, they will not be knowing the importance of the littoral drift. Why we have to study the littoral drift, like that they will question. And it is the very important kind of physical process we should know when you want to plan a port. Whether first of all that place is suitable for developing the port. Apart from the environment, the more problem you will have due to the littoral drift. So to plan the harbor and also to make out your dredging plan, you should know what is the sediment moving close to the place where you are proposing the port, and also the stability of the river mouth. Now Kuam is one of the very good example, got choked up long time back, Adaya river mouth and all. Many of the river mouths, they get silted up, they close the flow due to the littoral drift moving across the mouth and getting deposited over there. And similarly, the stability of the tidal inlet, like Pulikat or Chilaka Lake, any tidal inlet where during the high tide water enter inside the channel and during the ebb tide they try to come out. So that kind of mouth also is the stability or closer or it is active. This thing is defined by the littoral drift moving across the littoral, this tidal inlet. Beach erosion, shore protection, what we have in Ennur, really good. Impact on submarine pipelines, really good. Problems in seawater intake and outfalls. There are so many seawater intakes are there, and effluent outfalls are there throughout the world, also in India. So those particular facilities, either intake or outfalls, should not get choked up. Yes, the littoral drift, if they go and just they cover the intake, then we cannot anymore make use of that. And also in overall, you know that any morphological formation is the evaluation of the geological years. Today where the sea is there, yesteryears they were all land formation. Today where you have the land, they were all yesteryears was in the inside the sea. So this geological evaluation also is to some extent defined by the littoral drift and how they get deposited. And it is littoral drift is a natural process, but people in a very short term within their living span of that 50-60 years, everyone say we are getting, our place is getting eroded and we are getting unnecessary accumulation, like that. But it is not the case. Short term, you should not see how to allow this process to take over the geological years. Let them adjust themselves to take their kind of the shape what they wanted to have it. The problem has come as 1/3 of the population on the earth, they are living along the coastline, and everyone wanted to go as much as close to the sea. They want to go in sea resorts. They don't want to stay inland, so they want to go very much close. So in the process of going very close to the coast, they start disturbing the kind of stable equilibrium of the coastline. Once they disturb, they start disturbing you. So that's how it is. How you treat, you get back. And as you go very close, they say my bungalow is under threat and my buildings are under threat. For example, it is the Pondicherry. You can see the entire coastal stretch where they have all valuable properties. They are all under threat. They put a seawall. And again, tourism gets affected because, like you construct a seawall, then none of the people would like to go and visit the sea. Like Marina Beach, no one goes to Yenur, wherever you have the seawall. So tourism will tremendously get affected. And people start building artificial groins and seawall. These are all scar marks. Suppose you have a good, beautiful face, and if you get a scar on that, then how you look like. So the beautiful ocean, they got kind of very charming beaches, and because of erosion, they try to construct groins and seawalls. Then they totally spoil the look of the the coastline. And we disturb it by construction of ports and harbors, seawalls, and all. And it's a natural flow. We are going to talk more about what will happen by disturbing the littoral drift. And they also kind of, when you disturb, they disturb your existing kind of river system and all those things. And what is this littoral drift? When you see, put a kind of, here it is a coastline, it's a beach, and here waves are breaking. So beyond the wave breaking zone, if you go to Chennai Marina Beach, you can see about 80 meters waves are breaking from the beach. So whatever the kind of sediment moving beyond the wave breaking, the sediment movement will be relatively, the volume will be less. They are all called near shore sediment transport. And once the wave breaks, they stir up the sediment deposited in the near shore, and they kept in suspension, and they move either parallel to the coast or onshore, offshore. Like, they are called littoral drift, and we call as littoral sediment transport. So the movement of sediment from where the wave breaks till the waterline, that is called the littoral drift. And littoral drift, again, you have longshore drift, that is moving parallel, and another one is onshore offshore transport. They will go move perpendicular to the coast. I will be mostly concentrating on the longshore drift. Yeah, that is the one, the maximum volume of the sediment moving in the breaker zone. It is a basic definition you would have seen in your class when they talk about the coastal engineering. The red color is the wave orthogonals. They come and break. Always the waves, they make some kind of, they don't come parallel to the coastline. They make some angle and come and break. If you take any part of East Coast, either Vishakhapatnam or Paradip or Chennai or Krishnapatnam, you will have for 8 months, that is from April to the next September, you will have waves coming from south. And the another 4 months is October, November, December, January. You will have waves coming from the northeastern side, from your left side. So they make a kind of angle to the coastline. So whenever the waves they come and break, they will set up a kind of mass transport perpendicular to the wave approach angle. That can be divided into two components. One is perpendicular to the shoreline, another one is parallel to the shoreline. So the component of energy which is carrying the sediment parallel to the shoreline is called, that is longshore transport. The one which is taking inside is called the offshore transport. You can see here. And this, when the wave break, They also have a kind of uprush on the beach. When you stand, the water will come up and go. So that is the way it makes a kind of turbulence and take the sand from the beach and keeps in suspension and moves parallel to the coastline. And near shore sediment transport means beyond the breaker zone till deep water. And the factors causing the near shore sediment transport is currents and waves. They move in the form of bed load and suspended load. Bed load will be much higher than suspended load. When you come to littoral drift, they are confined only to the wave breaking zone, which we call surf zone. And the reason for littoral drift is the waves breaking in the near shore. They also go in the form of suspended load and bed load. And here the suspended load will have much more higher concentration than the bed load. And offshore onshore sediment transport means the part of the littoral drift which is moving into the sea and also coming back in the perpendicular direction. Littoral drift is the one which is going parallel to the shoreline. So when you talk about the sediment moving in the south zone, both onshore, offshore, littoral drift, one has to apply their mind and they should try to quantify. And why we need to, what happens with the littoral drift? Any coastal this thing, if you see form, they are not the stable form. They are all, you can say, they will be in semi-equilibrium condition. One, you can say, tide to tide, they will change the coastal formation to, to not a very great extent, to some extent. During high tide, you will have some kind of accumulation. During low tide, you will have some kind of erosion. If you have a beach profile, you can see that. And also month to month, you will have the change in the wave climate. Accordingly, you will have that different geometrical features of the coastline. And season to season, yes, some season will be the monsoon season. Wave action will be very high. You will have some kind of beach formation. When you come to a calm weather like March, April, Indian coast, you will have well-built beach, more accumulation and all those things. So the accretion and deposition pattern is very important when you want to delineate the shore front for construction of coastal structures or ports and harbors, and also when you want to plan for any kind of tourism activities, So we should know that. Similarly, erosion, the waves and currents also in some places. Suppose if we have a cyclone for 3-4 days, high wave activity will be there. They will remove a sizable quantum of sand from the beach. You will see vertical cliff and all those things. They will get eroded. They will go inside and they will get stored offshore. Again, they will try to come back. So that kind of erosion also happens via the sedimentary process. And if you people gone over the different parts of the coastline, you would have seen, most of the people have seen only the Marina Beach. They say beach. If you go to Muttukadu, you can see spit, And if you go to Pulikad Lake, the mouth, you can see this bar. You'll have bar and barrier beaches. And there are places you'll have Tambola. Tambola is the kind of offshore sandbar, not connected to the coastline. Crescent shape, you'll have sandbar formation. And offshore islands also you'll have. People who are coming from Odisha, they know that Mahanadi mouth and the northern side, another river is there. You will have beautiful, even this where you have rocket launching station, Wheeler Island and all. They are the offshore formation of the sandbars in Tamra. So very beautiful morphological formations we can see along the coastline. They are all created or formed due to the distribution of the littoral drift. And this is the typical formation of the spit. You can see any kind of major rivers. If you go to Krishna river mouth or Godavari river mouth, you can see this kind of spit. They extend from the shoreline and they get extended. And here it is towards south. If you see on Google map, you can see that Godavari river mouth and all, you will have the extension of the spit towards the north, extending 2 to 3 kilometers inside the sea prior to the coastline. This is one of the beautiful formation of the morphology due to the littoral drift. And these are all the barrier beaches. The typical example is Kakinada. People who had gone to Kakinada, they would have seen. Kakinada is a kind of slightly on the northern side of the Godavari river mouth. So whatever sediment had been brought from the Godavari river mouth, they all form the littoral drift, like a long, about 12-kilometer long barrier beach, and inside you will have a bay called Kakinada Bay, where they are operating the port. Is one of the excellent example for the littoral barriers. And tidal inlets, as I told you, one should go to Chilaka Lake and see the mouth. Even IIT also, they are the technical experts. Stability of the tidal inlet Chilaka Lake. This is one of the very challenging problem for the people who work on the littoral drift. Maintaining the, yes, the opening of the any inlet mouth, if it gets closed, gone case. The entire inlet, if you see Chilaka Lake, it's about north to south, about 80 kilometer long, and the water spread area east to west is around 40 kilometer. The entire system will be dead. Is one of the very, very richest kind of brackish water system. And if the mouth gets closed, gone case. So you have to maintain the seawater exchange coming inside and going for each and every tidal cycle. That is defined by only two parameters. That is the quantum of littoral drift moving across the mouth, and also how much water is getting exchanged in and out of the tidal inlet due to the tidal rise and fall. If these two balances, the mouth also will be stable. Otherwise, we will have problem. And IIT has given very good solution for this. And this is what kind of the inlet stability is defined by littoral drift. This already I told you a PPT how the littoral drift is taking place parallel to the shoreline. And this already I explained to you. Waves, they come with certain angle, and upon breaking that momentum parallel to the coast, perpendicular to the coast, they set up a kind of force. And this, if you throw a ball or the peeled coconut and the tenga matta, if you throw it in the breaker zone, you will see that they make a zigzag movement and they move in the breaker zone. They come, then they go inside straight, then again they come in a inclined line to the beach, again they go inside. So the sediment also there, it will go in a zigzag manner. And you can see here small animation is there. You can see how the littoral drift is moving from one side to another side. This is how it takes place. You can see that when they go, I told you that barrier beaches, how they develop. Sediment will get deposited, and there is a mouth, and you will have a formation of the inlet. So these are the morphological evaluation takes place. This now it happened in few seconds, but it takes over 300 to 400 years to get some kind of morphological formation. These are formation had taken place in Pulikar Lake and Chilaka Lake and all. And these are all the different. I told you that you have got a bay and you have got a lagoon, the barrier beaches, and these are all main beaches, Tambola formation and spit. You can see in the net so many kind of different morphological formation due to this distribution of the littoral drift, how they interact with the particular morphology on the coastline. This we can see where they come, break, rise over the beach. Then they'll have a backwash coming back, removing the sand and coming and moving along the coastline. And while moving in the coastline, if there is a kind of dead end, you will have a barrier beaches. And the point which one has to note, if at all you are going more in depth about the littoral drift is not the constant kind of physical process. Anytime, any day, it will be the same like that. It is like a wave. Each and every wave will have a one wave height and period, and it is a kind of a random process. Like the littoral drift also is a kind of random process. Is a totally a time dependent, and also place to place it will vary. If you go to Marina Beach near Mahatma Gandhi statue, the littoral drift will be something. If you go to Anna Samadhi, there it will be something different. So they are all spatially different. The mean values may be different, but if we, at all you have a measurement, if you see, there will be a kind of quite a big difference will be there. And it can occur on a mega scale and also meo scale. Suppose if at all you are capable of measuring the volume of sand moving in the subzone, if you record it every second, so the period of 1 hour you'll have a variation, it will not be a constant one. Similarly, mega scale, if you take it over the month, January how much, February how much, like that, that also will be varying, the littoral drift. How a person, coastal engineer, when he goes to the site, he can get some kind of first-hand information by seeing the beach. He will see the circulation cells, sediment transport trends, longshore variability in littoral current circulations. By seeing that waves coming and breaking morphology, he can assess and he can tell. In this particular beach, it is highly the littoral drift in one or kind of quantum of littoral drift moving here is very high order or it is low order, and whether really it has got impact or not. Any coastal engineer, if your professors they go there, they will by seeing that they will tell. And how the beach also responds to the system, that also they can make out. And okay, littoral drift is fine, sand is moving. Where from this sand is being brought into the littoral drift system, that is one of the very important aspects. Sand is moving, where from we got that sand. So rivers, if you see anywhere in the world, the major source for the sediment in the sea is the rivers. There are so many rivers, and some are due to biological process. Biological process is like if you go to Lakshadweep, if you go to Maldives and all, there also you have sand. That sand is not due to any rivers discharging over there. That is due to the corals, the fragmentation of the coral rocks. You get the coral sand over there. So biological process, and also you have a chemical process. Chemical process, you have to ask some chemist, some chemical reaction between this, that they will have some settlement like polymetallic nodules in the deep ocean. And how the rivers, whenever, there are geology, very well that whenever there is a rain, the catchment area where that rocks and all hills, they get slightly kind of erode the sand, years of abrasion or whatever it is, and the sediment particles get into the river, they flow and they reach the sea. So people say that 1/3 of the world's fluvial sediment load is carried by the major 12 rivers in the world. Whatever you have in the ocean, littoral drift, 1/3 of them is from 12 the major rivers. In that, the Ganges in India and Yellow River in China contribute 20% of the total. So these are all the value I given. You can just see how much it is and all. Mostly headland erosion and wind transport, they bring 2% of the river transport. And okay, there is an addition. Is there any loss of the sediment coming over there? Yes, like Manavala Kurichi and all Gopalapur, the people are doing sand mining. They take heavy minerals will be there, they extract and they use it for different purposes. So that kind of loss also will be there in the littoral drift. If you talk about the Indian coast, in Indian coast, if you see west coast, the major sources from Indus River, that is in Pakistan, Gujarat border, they bring the major part of the littoral, the sediment system put into the littoral dip. And if you take east coast, we have a large number of very big rivers, right from Brahmaputra in West Bengal, the Ganges, Brahmaputra, we have what we call Bengal fan. They bring a lot of rivers. You can see in satellite imageries how the deposits are there. Then we have Mahanadi, one of the major river bringing a lot of sediments, and Krishna, Godavari. Kaveri used to bring a lot of sediments about 50 years back. Now we have a lot of dams and barriers we are constructed along the course of the river. So they stop the sediments coming in. Now the Kaveri, if you see the river mouth, if you go and see a sea mouth, they are like a drainage. You cannot see like Godavari or Krishna. So now we do not have much sediment being brought by Kaveri river into the sea. And these are the quantities. And in India, you have 14 major rivers and 44 medium rivers and 200 minor rivers joining the entire east and west coast, and they bring the littoral drift. And one saddest part is because we have now most of the rivers, we have the major dams, and also government in all the state, they don't want fresh water to go and join the sea and get waste. That is actually a kind of a negative kind of impact for coastal engineers. Yes, that was one of the major kind of source for coastal engineers to keep the coastline stable. Now entire sediment coming into the sea system, about 80% is stopped. So we have everywhere we have problems. Like Kerala, we have 3/4 of the Kerala coastline deficit of sediment supply. They put seawall, and that's what happening in Tamil Nadu also. If you see peninsular tip, there are no sediments. Where IIT is doing a lot of seawall designs, and it is spreading now to Andhra Pradesh also. So we should feel very unhappy that we are not getting sufficient food for the stability of the Indian coastline. This is the kind of sediment cell which we need not to talk much, because this has been when the littoral drift moves, they are continuously moving, or in between they stop, they make a circulatory system. Suppose say that there is a littoral drift in Marina Beach, the same system is moving Krishnapatnam, Nizampatnam, then Machilipatnam, then going to Visakhapatnam, like that is going, or in between they break. So for that NCSCM, you know what is NCSCM? They have done a lot of work, and they made a kind of cells, different cells, and they say that littoral drift form as a close to a circular kind of system, and they are confined to that, and not it is a continuous one from Kanyakumari tip to the northern part up to West Bengal. And okay, yes, I don't want to go more into a kind of a scientific explanation. A sediment cell means it can be defined the length of the coastline in which you get that movement of the littoral drift system. And each system is defined by the sources and in which direction they are being transported and where they are getting sink. That is, a littoral drift, when you say, I told the rivers and all they bring, they are all called sources. They supply to the system. The opposite one is the sink. This littoral drift, at one place, they go and get sunk either on the coastline or in the sea. So it is like Like any evaluation process, there will be a generation and there will be another one. One is a kind of sink line. So in India also we have very well defined littoral drift sinks are there. And the best example I can tell that Palk Bay. So the whatever sediment is moving south during northeast monsoon, once they cross Nagapattinam and come south, you have got Point Pidaro, that is Nagapattinam, Vedaranyam. That side Sri Lanka, Jaffna will be there. So sediment will enter inside called Palk Bay. Once it enters there, that's all. You lost that. You lose that sediment. Once again, they will not come for your littoral drift system. So that is one of the major geological sink. Similarly, if you go on northern side, all entire Odisha coast on the northernmost, Balasur and all those places, Diga and all, very good sink. And lot of sand they get deposited from the water line. To get a 5 meter water depth, you have to go 10 kilometers inside the sea. That much very shallow near shore it is. And these are all people can go to NCSCM site and they can see these are all different sediment cell. Sediment which is moving here, they are confined with this cell. And from Dhanushkodi to Point Kalimer is another cell. Like Kakinada to Bimini-Patnam is another cell. That is, theoretically, it is assumed that no sand is going north of Bimini-Patnam from this cell. Similarly, nothing is going south of Kakinada from this cell. So like that, they define. This goes almost true with the physical concept if people they know about the littoral drift along the east coast as well as west coast. And I told you about the sink. What are the different kind of sinks? The first one is the accumulation on the beach face. Yeah, most of the littoral drift they get deposited on the beach face, and water will retreat inside the beach, which has got about 500-meter width now. Maybe after 10 years, it may be 1 kilometer. Here's the accumulation of the sand. The very good example are like Odisha coastline, even Andhra coastline also you can see near Krishna Godavari river basin. Gopalpur and all, you can see the beach. Sand dunes will have 10 to 20 meter elevation and very wide. If you walk from the high tide line into the land for about 10 kilometer width, you will have only beach formation. So such kind of accumulation on the beach face will be there. And they are all the beach that develop due to the island transport. Also, some of the beach they get deposited in the lagoons and river estuaries and the sand spit I told, and offshore bars like Wheeler Island and all. And near shore bed, I told Balasore, we have got a very shallow bed they deposit. And offshore, you'll have offshore island, they get deposited. And if you have harbors, the entrance channel, you will have deposition people, they do that maintenance dredging like that. Every day do 500,000, 1 million like that. Those sediments are brought by the littoral drift and they got deposited in the entrance channel. So that is one of the sink. And marshy land called tidal flats, they are called. And very wide tidal flats will be there. If you happen to go to Gujarat, if you cross Mumbai and go northern side, the kind of beach exposed between low tide and high tide is about 2 to 3 kilometers. So that kind of shallowness we got because of the littoral drift getting deposited over there. You can see they are very common in Gulf of Kutch and Gulf of Khambat in Gujarat, and backwaters in Kerala you can see. So as I told you, Gulf of Kutch, Gulf of Khambat, Gulf of Mannar, Palk Bay and Sandheads in West Bengal, they are the major littoral drift sinks. And littoral drift, okay, how do you define the littoral drift? We say volume of sand moving over the period of 1 year, and also what will be the net direction. Yes, if you take any coastline, each month they will have one particular direction. For east coast, if you see, October, November, December, January. October 15th, you can say February 15th, you will have littoral drift taking place towards south because of the waves coming from northeastern side. And rest of the months you will have towards north. So you have to see how much sand is moving over the 8 months towards north, how much is moving towards the south over the period of 4 months. What will be the net volume, plus and minus if you put it, then you say it will be towards north, and what would be the volume we call net transport. And you can assess that. Mostly we all do it either IIT or NIOT. We will have very good wave data and wave height, wave period, and also the wave direction. With that we can estimate the littoral drift, and that has to be compared with kind of your field studies. Theoretically we cannot go, this is what's happening over there like that. So the coastal engineer will go and he will see the morphological drift indicators, whether what we estimate is okay or not. And to have a kind of estimate, one should have at least minimum 1 year wave data, 1 year continuous wave data recorded for every 1 hour, wave height, period, and direction. If you have over the period of 5 to 10 years, then they are very nice to estimate reliable littoral drift. How to estimate the littoral drift? Professors are very thorough with that, and one can quantify from the dredging records of any port, and also a kind of growth of the spit. Okay, 10 years back the growth was like this, now it has come this much, so this is a kind of accumulation of sand one can quantify. And theoretically we have a coastal engineering research center, CRC, which you will see in any coastal engineering book. Energy flux method you can calculate. To calculate that, you need to have a very good information on wave height, wave period, and wave breaking angle. And this is what wave height and period and breaking angle. With this, to some extent, you get, this is the only way now we depend on estimating the volume of littoral drift, but this has to be tuned for the field, which any experienced scientist or professors or people like us, we can tell. Theoretically, if you go, this is the value, then people may not get satisfied. In general, see, I'm not talking more on the west coast. Yeah, west coast has got a lot of headlands, vertical cliffs, rocks, and also they are not a very good example of the continuous movement of the littoral drift. Whereas in contrary, on the east coast, we have not much any kind of hindrance for the littoral movement other than rivers. A lot of sand is moving. They are well defined by the littoral drift. So if you see a high drift, a coastline having very high drift volume of littoral drift, means they will go from 0.5 to 1.5 million cubic meter over the period of 1 year. There's a total transport. And the net transport along the east coast varies from 0.2 to 0.5 cubic meter per year. And if you cross Vishakhapatnam and go northern side, you will have only unidirectional transport. Further north of Gopalpur, you will not have the transport, significant transport towards south. All 12 months will be moving towards north. Yeah, there are no waves coming from the northern sector. And the net transport moving north minus moving south. If it is zero, then we call as the nodal drift, balancing drift. This particular coastline where you have over the 1 year period, you will have a balanced littoral drift. They are stable beaches. This kind of nodal drift locations we can see from Vedaranyam up to Kadalur, and also there are some part of Nizambatnam area you have nodal drift zero. And I have told you how much it will cost, the same thing. And for open beach, what would be the expected sediment transport, and partly protected 500,000. We like, if you have a bay like Nizambatnam and all, you will have about 0.2 million. Where you don't have any waves, like Palk Bay. Palk Bay, if you go, whenever there is a wind, there will be some waves. Otherwise, all 12 months, you will not have any waves. There will not be any littoral drift. And also, if you go south of Rameswaram, like Kilakarai and all those areas, not much waves, you will not have littoral drift. And also wherever you have rocks. See, littoral drift means that is due to the sediments moving. There are coastline, you will have only rocks. There will not be any sandy beaches like Kanyakumari. Waves are breaking there, but only rocks are there. There is no kind of a sediment system to define littoral drift. So there are also littoral drift. Any people they ask, you should tell there are no littoral drift. The rocky coastline. This is very kind of typical phenomenon is Saurashtra coast. If you go to Gujarat, right from Woka up to this Bhavnagar, the entire coastline is totally exposed with rocks. So though you have beaches over the littoral drift means it will be very, very small order. These are the equation you can see in a textbook to estimate that. And this is the old equation. Now revised equation is that which maybe in another 2 months you can see my book or you can refer coastal engineering manual. You will get when you give the wave height in meter, wave period in second, wave direction radians, you will get the volume of littoral drift for meter cube per year. You can get it. So these are all the eminent people CS equation, Chopin-Texnel, Cambus, Walton, Bruno, Comer. Comer is the person who worked very much on the littoral drift. And there are some 5-6 people, the entire life they spent on defining the littoral drift to some reliable extent to quantify. These are the different equations. You can see even Professor Mani's book or Professor Sundar's book or Dr. Murli and Sanasiraj, they have the public books in that it is written there. And estimation of this, you can directly estimate. Nowadays, a lot of softwares are there given by Delft Hydraulics, DHI and all. They also have a mathematical, nothing. It's not a very big thing. They are given the formula. So it is like a touch and get the result. Like if you give a height, it will evaluate, quantify the littoral drift. So this is what you need, what kind of sediments, wind, wave, current data, angle, and you can estimate the longshore current. From there, you can estimate the littoral drift, and that's all. And is a typical kind of littoral drift process one can plot for R&D purposes. So this typical wave roses, and these are the volume, and this is the orientation of the coastline for a given set of coastline. If you have this much angle, then you can read from here how much is the volume of net transport, how much is the gross transport, and this gives a very good input. People who are going more in R&D, they have to prepare such kind of courses. In my thesis is there an IIT, it will be available with professor also. One can see we are given for entire coastline, but they are all outdated now. We are now revising that. And this is a typical coastline. How is the annual and net transport? I'll show you much better one. And this is already I told you how this. When you see the littoral drift, we say totally quantity, but how that quantity is distributed across the subzone. This is a wave breaking zone starts here. Will it be constant till the water line or they vary? So this is the quantity distribution across the subzone. So at middle of the subzone, you'll have a maximum volume moving. That extension of the sediment transport will be there even beyond the breaker zone to some extent, maybe up to 50 meters. This also you can see in his standard books. They are given what is the distribution of the littoral drift across the subzone. And these are different experiments. It's the ASC people have made and putting so many instrument, everything. These are wave breaking zone and volume of sediment transport. You can see how they are. And one thing very important one is, suppose there is a PhD student, he cannot use the equation and say, I will use the same equation, well-versed equation, and I got the wave record, and the transport in the month of March is this many cubic meter, like that. It is not true. And here everywhere, it is the experience. The one which you estimate for one segment of the coastline may not be the same to the other place. So littoral drift is mostly moderated by the experienced oceanographer and coastal engineers, and they come out with the final figure. Theoretical knowledge will not help. Theoretical knowledge will tell what is the direction of sediment transport, but quantum has to be defined by the experience. And again, this littoral drift, when they move, they bypass wherever you have natural barriers, like you have man-made structures like breakwaters, groins, and all. They try to bypass the tip of the breakwaters. And suppose if you have headlands like Mahabalipuram, you have the headland, and that doesn't mean that the littoral drift will totally stop on one side of the headland. They also try to bypass. So that is what IIT also is doing some research on that. And wherever you have the river like Krishna, Godavari, they come rivers, they come like a water jet, that discharge 2 meters per second and 3 meters per second, they come and meet the sea. So that also like a hydraulic barrier for the littoral drift. But still, the littoral drift will join with that river currents, go into the sea, make a circle and come back to the other side of the coastline. So this is the way they bypass. And this is Kanyakumari coastline. We have done some studies. You can see here Muttam Harbor and all those things. How a particular littoral drift is taking place, and we have onshore, offshore, and they bypass this and go. We have got some data on this, and this I told you. And this is a kind of I'm almost coming to the end of my presentation. How to make the field measurements of a littoral drift and a wave breaking zone. There are now a lot of equipments are there. You can put sensors and measure. This was done in 1986. That time there was not much equipment. This is myself and my NIO colleagues, and we used to take the sampler bottle, and about 10 people will be standing at different locations. When the wave breaks, we will do the water sampling and get the suspended sediment load. This is one of the immediate way of measuring the sediment load. There is sediment in a suspended form. And if you know the longshore current also simultaneously if you measure. So velocity into suspended sediment is the transport in one direction. You can see here how we are doing it. This is rip currents. See, normally why the littoral drift is not a continuous cycle. They break in between. That is the kind of creation by the God. It is not like a physical concept can be defined by the coastal engineers. God himself made a physical process such a way that a sand which is being carried is get kept within a kind of closed circle. So in that, the rip current plays a very important role. The flow of current along the coastline, they break and they get into the sea, and sediment they get deposited. You can see this animation. These are rip currents. This is the rip current going inside. These are the rip currents. Sediment is moving inside and they get deposited. Okay, now Dr. Atmanand and Dr. Sanyasila, they know. I have brought out a kind of book which will be released in the next forthcoming conference in February. And that talks everything about the littoral drift for the east coast of India, Kanyakumari to Sand Ends. and it is going to be the e-version, free, without any charge. I'm publishing this book with all what I had done last 40 years. That time you will get the link. Anyone who is interested, they can download, they can use it, and it is unpriced kind of edition in order to kind of give a kind of very good kind of knowledge base for defining the littoral drift for the east coast of India. And book is almost ready, and we are waiting for the conference to publish. And the book will have this kind of contents, which whatever they kind of academicians or researchers or engineers they need on the littoral drift, they are there yet to use it. But still we have kind of every year we wanted to just add materials and improve the value of this book. It is the entire east coast. We are divided into 14 zones, and each zone we have used actually measured data compiled from INCOIS, NIO, NIOD. Those data have been used, which was not the case in my 1985 publication. They're all ship reported data. This will be more reliability. And again, I told, with our experience, we have moderated the littoral drift, not simply what the equation gives. That book also gives the wave climate for the entire east coast. So people can straight away start using this. They can do their consultancy. I'm not going to ask anything. So you'll have but much reliable information on the waves and also the littoral drift. And like this, I have presented for every 10 kilometer along the coastline, for each state, I'm giving the what would be the volume of littoral drift for every month. So this will be very good information. This is for Andhra coast, this is for Odisha coast, this is for West Bengal. And this is my end of presentation. Thank you very much.
Thank you, sir.
Yeah.
Now we will take a few questions. If at all there are any questions by the participants, they can put it in the chat box, so that we will take like a few minutes to answer the question.
29 people, yes. Ask some question, so that I will also feel happy that at least some question people are asking. They had some kind of attention on my talk. At least coastal engineering people can ask. I think Mr. Danish, I think no. Well, one, either they have understood everything or they have not understood anything.
So you are very clear, sir. That's the reason. You are very clear in your statements.
Yeah. And it was nice. If you ask little drift, I can go on talk hours together, but now let us stop here.
Okay, sir.
Okay.
Thank you.
Thank you very much. Thanks to everyone.
Yes, sir. Danish, please continue.
Yeah. It's my privilege to propose the vote of thanks for this webinar series, which has commenced from today. I would like to thank our speaker, Dr. P. Chandramohan, Managing Director, Indomer Coastal Hydraulics Private Limited, who has inspired us with a very knowledgeable lecture. I would like to thank Chair, IEEE OES Madras Chapter, Professor Sanasiraj, IIT Madras, and I would like to thank all the organizing members for making this possible. I would like to thank each and everyone of the participants who have spared their time and attend this webinar. And for all your information, the next lecture will be by Dr. G.A. Ramadas, Director, National Institute of Ocean Technology, on Samudrayan, the Indian Manned Ocean Mission. That will be happening on 11th November 2021 at 4 p.m. That is 1600 hours Indian Standard Time. Thank you.
Thank you, sir. Thank you all.
Thank you very much.
Thank you.
Thank you. Thank you, sir.